Hey guys, so today you and I are going to talk about principles. So let's get into it. So the question in question was, Frederick, do you have what are some of the guiding principles that you follow as a software developer? Well, it's going to be the same two things I said last time we had this discussion, and it's going to be first and foremost, keep it simple, stupid, and the second one is write disposable code. What I mean by that is very simple. Keep it simple, stupid means that usually the goal is not, and that is something that is very difficult for some people who have this tendency to over-engineer things. Do not mistake what you do for art or anything like that. The goal of engineering is always to find the cheapest, most affordable, simple solution to any given problem, and it depends on the problem on how difficult something should be. An example would be, I like to say, if you're going to water a potted plant, you can do that with a fire extinguisher or like a fire hose from a fire truck, but it's probably better to just use a little cup of water or something like that. That is what I'm saying. It's the same thing as if you're gonna solve cold fusion, or like you're going to solve the electrical crisis or something like that, or like the energy crisis across the world, and so forth and so forth. That is a problem that is more complicated and therefore warrants a more complicated solution. But you should never make something more complicated than it has to be, because you're usually just going to invest more than what you're going to get back, and it's very likely that a simpler solution is going to be the thing that wins anyway. A short story from my own life was that I was working with a software developer a while back. We were working on a high integration system, and he started in my team, and the first complaint he had was that we were handwriting all of our REST clients. And I knew he was going to complain about that, because that is usually the thing that the philosophers complain about the first, like immediately, and then they very quickly stop complaining after a little while, and I'll tell you why. And so you want to be supported, because in this specific scenario I was the team lead, so I said, yeah, but if you have a better suggestion, let's just go for it. Just be aware of that, we have had, I think he was like number 7 or something like that who had done this, and he had literally the same idea, but you can't say that because that's going to put the demotivator on him. And so he says, oh well, Frederick, it's better, instead of handwriting your REST clients, it's duplication, you're doing that work over and over. And I go, yes, but it's actually not that simple. He didn't really hear me out, because I said to him that when you say that you're going to be dry, it depends on what you mean. Technically, dry is that you copy paste the exact same code, or you do the exact same thing over and over again, but you're not, because this code is just very similar to other code, and that is a very big difference. And so he said, yeah, but you could generate all of these clients, you know that, right? Yes, you could do that, but unfortunately we don't have we can't make an assumption on that each of these APIs that we're working towards has an open API spec or something similar, like the documentation is in a format that we can generate. And he sort of ignored me there and said, yeah, but you could still do it for some of them. And I'm like, yeah, but usually the software developers, that they usually prefer to have solutions that are like holistically just, it's the same, it's the standard, if that makes sense. Because when you introduce more than one way of doing things, it's usually not something people just get used to. They sort of, like, it's always causing in many cases it does just cause extra confusion for people. And so he goes off and he creates this auto-generating tool, and it turns out exactly as I said. It turns out that he created this thing, and he realizes that the reality is that whenever we are creating new integrations, sometimes we get documentation that is in a format that we can use to generate the client, and in some cases he was forced to just admit that now I have to like rewrite a Word document into an open API spec, etc., to make my solution work. When I said, yeah, and if you count how much time you're putting into making this code, this generator work, versus how long it took me to do the thing that I did. Because the thing that I did was that I created a template file, like a template REST client, for connecting to all these different APIs. It was basically just a class that you implemented with a new endpoint, and like it took less. You copy pasted another one of these because we had tons of these integrations, right? You just copy pasted another folder or like a different file, changed the path and like the connection information, which is like a few seconds of work when you have the documentation, and then you were done. The total time it took to implement a new client was less than it took him to create a generator. That's not going to work 100% of the time. This will work 100% of the time. And it turns out that he spent this time and none of the coworkers wanted to actually used it. So we just committed it. It's still, I'm not sure if it's still there, but nobody uses it. That is not keeping it simple. That is you being in love with your solution more than you are focusing on solving the problem in a sustainable way. So that's number one. Number two is be very good at writing loosely coupled code, because code always changes. So to give you an example of that, the way that I was working with a company that had a gigantic problem, and that problem was that they had a team who had created a microservices architecture where they could not scale the system, because the people who had created this system had created such a strong coupling between all of the services that when they deployed things, all the systems, they depended on the exact version of each of the other systems. So you could never actually do an independent deployment of a single service, which is kind of funny. Because that means that my coworker said that to me, Frederick, they built a monolith. And I go, yes, they just moved all the code, or like all the service layers to the network. That's all they did. Because if you have to deploy the whole thing as a single unit, you are technically doing the same thing as a monolith. It's just that the code lives in different repositories. And so the company was very unhappy, because basically they could make no changes to anything without synchronizing with all the other teams. And as you can imagine, for a large company, they want to move as quickly as possible, and this was slowing them down. So they actually moved all the they started moving. The company migrated. So they basically, I'm not saying they didn't fire people per se, but they replaced everybody, and most of the people who were working there quit, because they didn't want to get they basically got demoted. And so that's an example where they didn't really understand that when you create a solution where you can't actually just go in another direction at practically any moment, that's not a good solution in IT. You have to design systems in such a way that you can move in any direction almost at the drop of a hat. Business always changes their mind, always. It can happen whenever, right? Which is sort of the idea of a microservice, that you should be able to change it independently of each other, etc., etc. Anywho, an example of when we did that in a very good way, I think at the very least, was when basically we had a requirement for creating a platform for a international company, a gigantic platform. We're talking the size of Amazon, like AWS or GCP or Azure or something like that, but for internal systems at the company. And so the way we did it was very simple. We realized that we don't want to create a monolith here. We don't want to create one super application, because that has already been tried 100 times over. And all the different departments that had different existing systems, like they had different code bases, they had different, etc., etc. And so what we did was very simple. We created a domain where all of these systems could live, and then we created a navigation menu where all of these systems could be deployed into a Kubernetes cluster. Each of these existing systems, they're isolated. We put them in an actual monorepo, and not everybody had to live in the monorepo, but we tried to put as many people as there as possible. And the only overlap that they had was that we all agreed on a URL scheme. This is the old thing that you did with Tomcat, or like the old Java application. You still do that, right? You simply said that, okay, here is the host, like the domain that you access, and if you want to go to one of the systems, you just add a slash in there. You add like the product name, and then you're in a subfolder, a subdirectory. where you can access that system. And then we centrally just moved people, like we provided basically a navigation menu that the different people in the company could use in order to move between systems. But each of the product teams, they could deploy independently, they could maintain things the way they wanted, etc., etc., and then we worked together to sort of create standards and so forth. But there was no, like, it was you can basically think of it as a kernel pattern, where there is one entry point into the system where the domain lives, but all the different modules, like all the different products that were on that platform, could change at the drop of a hat. And so people could join, like they could add their own product and just spin up a new server and add themselves to the navigation, and then people could use their system as part of this platform. Or they could leave and go and host on somewhere else or do something completely different. And in the background, my engineers and myself, we worked towards making the stack as similar as possible so we could share code and things like that. So functionality that might have just lived in one system could be moved to another system, etc., etc. And yeah, that was a very, very flexible system. You can look that up if you want to. The kernel pattern is it's a good example of a design pattern that has built in by default this idea of writing very disposable solutions, because a kernel pattern basically means that you can add or remove things or change them in practically any way you want at any time. So what I want you to take away from this is that I only have two really strong principles that I follow in my journey as a software developer. Number one is keep it simple, stupid. Because, as I said, only the people who are making a sophisticated solution likes that it is complicated. That's where over-engineering starts happening, and people shouldn't be doing that as software developers. Create the right solution for the problem that you are dealing with. And if that's not something that you feel is up to your skills, or like you don't get yourself to stretch yourself, like stretch your muscles or show off, I suggest that you go and find a different problem instead of trying to shoehorn in a very complicated solution on a simple problem, because you're just going to fuck everything up. Second thing is write disposable code, because I guarantee you that code always changes, and it's almost impossible for you to know in exactly what way. So the better if you create a very strongly coupled solution where it's very difficult for you to make any changes, you're locking people in, and people don't like being locked in. What you should go for is a more flexible solution, or a solution where rewriting the system or changing a part of the system or adding something, removing something should be very low effort. That is the best state that you can be in the average IT company. Have a great day.